All right, guys, on this video, I'm going to go over how to do all of the evens from the review. All right, so we'll start with number 2. All right, and this is finding the domain in interval notation. Okay, so first thing to check is to make sure it's not an odd root. It's not, it's even, it's 2, which means you have to set whatever's underneath the radical equal to 0. All right, so I get negative 5x equals 1. So x is equal to negative 1/5. All right, so that's what you're going to put on the number line. All right, so we put negative 1/5. All right, so we put something a little bit smaller than it, a little bit bigger than it, and we see if it's positive or negative. And we're going to look wherever it's positive, that's going to be our answer. So if I put 0, all right, I put 0 in here, I get a negative number, which means most likely this is going to be a positive. If I plug in, let's say, negative 1, negative 1 times negative 5 is positive 5 minus 1 is positive 4. So anything less than negative 1 in this interval here, that's where I'm going to have a positive. And I can't have a negative inside of a even root. All right, so your answer is, change color. So it is negative infinity to negative 1/5. And negative 1/5 is what gives me 0. It's okay to have 0 underneath the square root. So you put a bracket. So negative infinity to negative 1/5. All right. So for number 4, check it's an even root. So we have to go through and do it. If it was an odd, it'd be negative infinity to infinity. So we set this equal to 0. Well, this factors to x plus 9, x minus 5, which means I have negative 9 and positive 5. All right, that is my 2 numbers that make it equal to 0. So I pick like negative 10. Negative 10 makes that a negative, that a negative. Negative times a negative is a positive. Put in 0. 0, that is a positive, that is a negative. Positive times a negative is a negative. If I put in 10, 10 plus 19 is a positive. 10 minus 5 is a positive. Positive times positive, positive. So this interval and this interval, so that's negative infinity to negative 9 bracket union bracket 5 to positive infinity. Right? All right, now moving on to the rest of the problems where we're either simplifying, adding, multiplying, subtracting, radicals, or dividing. All your answers have to be in radical form. All right. So for the first one, the cube root of 189, b to the 9th, d to the 17th. All right. So this is like 3 separate problems. You guys simplify the cube root of 189, then you got to do b to the 9th, then you got to do d to the 17th. All right. So 189 is like, what goes into 189? Well, we can do a little factor tree if you can't think of what like perfect cubes go into 189. Since it's 1 plus 8, which is 9, 9 plus 9 is 18, it's a multiple of 3, so I can just multiply 3 into it, and that goes in 63 times, which then is 9 and 7, which is then 3 and 3. So 1, 2, 3. I have 3 3s and a 7. So since it's a cube, all right, and I have 3 3s, that means a 3 gets to go on the outside. And what's left over to stay inside? There's a 7. So the 7 goes there. All right. For b to 9th, how many times does 3 go to 9? 3 times. So b cubed on the outside, what's left over? Nothing. Goes in evenly. So there's no b on the inside. 3 goes into 17 5 times. So it's d to the 5th. And then how many are left over? 3 times 5 is 15 with 2 left over. So it's d squared. So 3b cubed, d to the 5th, cube root 7d squared. All right, 8. When you have this, a negative exponent, all right, so this really means 1 over, I can put this in the bottom, negative 27 to the 2/3. All right, and to evaluate this, negative 27 to the 2/3 is, so I got negative 27 in here, What root is it? It's the bottom one, which is 3, and then squared. You could do negative 27 squared, but I have no idea what negative 27 squared is off the top of my head. But I do know the cube root of negative 27 is negative 3, and I know negative 3 squared is 9, which means the answer is 1/9. All right, let's scroll down here. All right, we do the even, so we have 10. All right, cube root of 7 times the cube root of 7 times the cube root of 7 is the cube root of 7 times 7 times 7, which is just the cube root of 7 cubed. I don't need to multiply it out because what's the cube root of 7 cubed? 7. All right, 12. Let's distribute. 3 root 2 times 5 root 2 gives me 3 times 5 is 15. Root 2 times root 2 is 2. 15 times 2, 30. 3 times 7 is 21. Root 2 times root 3 is root 6. 30 minus 21 root 6. I cannot simplify that any more. All right, 14. These look like they're almost conjugates, but they're not because there's 2 here. So you got to foil this all out. So 2 root x times root x is 2x. All right. 2 root x times root y, that is 2 root xy, right? And then negative root y times x is negative x root xy. All right, so it's my 2 middle terms. I can combine them. They're both xy underneath the radical. So 2 minus 1, which is just 1. So it's going to be plus the square root of xy. And then root y times root y is just y, and it's a negative because one's positive, one's negative. And there is your answer. 2x plus the square root of xy minus y. All right, 16. All right, 16. All right, this is 1/4. There's a couple different ways we can do this. You can think about this is the 4th root of 16, a to the 8th, b to the 4th. Or you could just do 1/4 to all of these and simplify here. 16 to 1/4 is this 4th root of 16, which is just 2. 8 times 1/4, right? Power to a power, you multiply. 8 times 1/4 is 2, so it's a squared. But if we did it this way, where the 4th root, 4 goes into 8 2 times. So you'll get the same answer either way. And then 4 times a 4th is 1. Since they all go evenly, it's easy just to distribute here. If they didn't, it'd be easier to rewrite as a radical first. All right. Either way is fine. 2a squared b. All right, 18. We have 3 to the 1/4 times 27 to the 1/4. All right. Since they're both the same thing, it's just really the 4th root of 3 times the 4th root of 27. 27 is 3 cubed, so or 3 times 27 is 81, and 81 is the same thing as 3 to the 4th. And what's the 4th root of something to the 4th power? It's whatever that is. So the answer is just 3. All right. Since these are the same roots, you can multiply whatever's on the inside. All right. 20. All right. All right. So for this one, let's do this. Let's distribute the 2 and the 1/2 to all of these and look to combine them. So 1/4 times 2 is a half. So I get m to the 1/2. N to the 1/2 times 2 is 1. So it's n to the first. So I have those. All right. Times m to the 2 times a half is 1. So it's m to the first. And then I get n to the 3/2. All right. When I multiply, what do you do with the exponents? You add them. So m to the 1/2 times m to the first is m to the 3/2. And then I have n times n to the 3/2, which is n to the 5/2. All right. So now I want to change this to radical form. The n to the 3/2, n to the 5/2. Well, since 2's on the bottom for both, that is the square root of m cubed and n to the fifth. And I'm almost done, but I could simplify that. All right, 2 goes into 3 one time, so I can take an m out with 1 left over, and I could take 2n out, n squared, with 1 left over. So it's mn squared square root of mn. Excuse me. All right, so for a problem like this, all right, I'm going to show you the y it's equal to that. I'm just going to show you a quick shortcut. So what this is saying is it's the square root of the fourth root of 7. So I could rewrite this. The fourth root of 7. If something is the square root, it's really, this is going to the 1/2, right? Could rewrite it that way. This I can rewrite as 7 to the 1/4 to the 1/2, and power to a power, I multiply. So this is 7, 1/4 times a half is to the 1/8, and then I can just change it back into a radical. 7 to the 1/8 is the 8th root of 7. Now, if you see this one again, easy way to do it, square root, right? So that's really a 2. Just multiply 2 times 4 is 8, 8th root of 7. If that was a 3, if this was the cube root of the 4th root of 7, the answer would be the 12th root of 7, because 3 times 4 is 12. All right, this is why it works, but you can just multiply. All right, you want to be efficient. All right, cube root of 3 times the square root of 3. They're not the same root, so you cannot just multiply them 3 times 3. You got to rewrite them as rational exponents. So it's 3 to the third times 3 to 1/2. Since I have the same base, I add 1/3 plus 1/2, which is 2/6 plus 3/6, which is 5/6. All right, so I added 1/3 plus 1/2. All right, so that rewrite as a radical the 6th root of 3 to the 5th. Can't be simplified anymore, right? Because this is 6. I need more than 6 of these, at least 6 of those, to be able to take something out. And 3 to the 5th, hopefully you guys know that. 3 to the 5th is 243. And there's my answer. All right, moving along. All right, 26. All right. We have 12 cube root of 2z to the 5th. And then we have z cube root 54z. They are not the same. So let's see if we can simplify and get the same, each of them. If they're not, then we're going to be done the problem. All right, so I have 12. The 2 I can't do anything with, right? But z to the 5th, 3 goes into 5 one time, so I can take out a z. And then I would have the 2 still in there. And then I have a z squared. Minus, all right, 54. This is the cube root of 54, right? Forgot about the cube root there. 54 is 27 times 2. 27 is a perfect cube, so it means a 3 could come on the outside. There's already a z out there, and I am left with the 2. Then the z squared, I can't take that, so I have z squared. So now I have 2z squared, 2z squared. I can now combine them. 12z minus 3z is 9z. Cube root of 2z, not very good 2, sorry, squared. And there's your answer. All right, 28. 5th root of 64. All right, 64 is 2 to what power? It's 2 to the 6th. So that means I can take out a 2. Right, and have 1 left over. X cubed, 5 doesn't go into that, so all the x's stay in, nothing gets to come out. 5 goes into 15 3 times with nothing left over. 5 goes into 7 one time with 2 left over, and there's your answer. 2y cubed z, 5th root of 2x cubed z squared. All right, So moving on to the second page. Nice one to start off with. All right. 8 to the 2/3, which can be rewritten as the cube root of 8 squared, or the cube root of 8 squared. So, but it's easier to just do smaller numbers. Cube root of 8 is 2. 2 squared is 4. So 8 to the 2/3 is 4. All right, 32. All right, we have a radical on the bottom. We can't have that. We have something plus or minus it. So we multiply by the conjugate. So multiply by 5 plus root 3 on the top and the bottom. All right. So remember, this is in parentheses. So distribute the 2. 2 times 5, I get 10 plus 2 root 3 over, since I'm multiplying by conjugates, you just have to do first and last. So 5 times 5 is 25. Root 3 times root 3 is 3. So 25 minus 3 is 22. So I get 10 plus 2 root 3 over 22. However, I can simplify 10 over 22. 2 goes into that. 5 over 11 plus 2 and 22. The 2 cancels out. Root 3 over 11. Or 5 plus root 3 over 11 also works. All right, either of those would be acceptable answers. All right, 34. We have a cubed root here. I'm going to just kind of write this over here. So we have a cube root in the bottom. I don't just multiply by the cube root of 2, right? Like what I do with square roots, because cube root of 2 times cube root of 2 is cube root of 4. That doesn't get rid of the cube root. So I need to multiply by the cube root of some number that when I multiply, I get a perfect cube, so it cancels out. So if I have a 2, if I can get a 2 cubed, right? This is 2 to the first. If I can get a 2 cubed, that's going to, cube root of 2 cubed is just 2. So what gives me that? 2 squared, which is 4. All right. So I get 3 cube root of 4, which is, this is the cube root of 2 times cube root of 4 is cube root of 8, which is just 2. There's your answer. 3 cube root 4 all over 2. All right. All right, so 36. Cube root of 15x squared divided by the cube root of 5x. All right, so I'm going to rewrite this as, like to look this way, which I think is going to be easier. Now, remember, you are allowed to simplify what's inside with inside. So if I change colors here, the 15 becomes a 3. This is a 1. That's a 1, and this is just an x. So all of this cancels out to cube root of 1, which is just 1. So the answer is just the cubed root of 3x. We're done. We don't need to do anything else. All right. So for 38, all right, for 38, we could rewrite this as the 4th root of 3 over the 4th root of 4x squared. Okay, so I need the 4th root of something here. Multiply top and bottom by, so that I can cancel, so I get a perfect 4th root of something here. Okay, now you could just be like, oh, that's 4. I can get 4 to cubed and get 4 to the 4th. That's fine. But if you have a number that you can rewrite as something, for instance, this is 2 squared, isn't it? 2 squared, x squared. So if I got, what would give me 2 to the 4th, x to the 4th? Well, it would just be this again. 2 squared, x squared. Right? That gives me that, which would give me 4x squared. Now, would you be wrong if you put like 4 cubed here, which would be what, 64? No, you would just have more simplifying to do at the end. Okay. So multiply these together, and I get the fourth root of 4 times 3 is 12. I get 12x squared over 16x to the fourth. So my final answer is just the fourth root of 12x squared all over 2x. All right. Now, do you have to show this step? Could you have gone right to 2x? Yes. All right. But just in explaining it, I want to show you why. Your goal is to get a perfect something that is a fourth root, goes in evenly. Okay. All right. Last problem. All right. Number 40. All right. Where we have two radicals at the bottom being added together. So we're going to have to multiply by the conjugate. All right. So that's going to be root 2 minus root 6 on the top, and very messy, minus root 6. Okay. All right, so we're going to FOIL all of this out here. So let's go. All right, 2 times root 2 is 2 root 2. All right. 2 times negative root 6 is negative 2 root 6. Negative 3 times root 2 is negative 3 root 2. This is supposed to be a 6. I know it's bad. Sorry. Root 3 times root 6. It's the negative times the negative, which would be a positive. That's the square root of 18. All right. And we'll go and simplify that in a second. All right. And then on the bottom, they're conjugates. So it's root 2 times root 2, which is 2. Root 6 times root 6, which is 6. Subtract them. Okay. All right. Now we do have some things with root 2s. What is square root of 18? Square root of 18 is, what is that? 9, it's 3 root 2. So if I look here, I have negative 3 root 2 plus, and as I'm looking at this, I realized that, hopefully you realized that, you see, oh, Mr. Gillen, you made a mistake here. When I did this times this, it's not 3 root 2. This is the square root of 6. This is negative root 6. Okay, apologize. So I do have things that you can combine, though. I have 2 root 2 and 3 root 2, which is 5 root 2. And I have negative 2 root 6 and negative root 6. So we can combine them to get, oh my gosh, negative 3 root 6. And then 2 minus 6 is negative 4. Probably be okay if you just left it like that. If you want to split them up, be negative 5 root 2 over 4 plus 3 root 6 over 4. Or you can rewrite it as negative 5/4 root 2 plus 3/4 root 6. It doesn't make a difference, but I'm okay if you just leave it like this. All right, so there's all the answers review. Hope that helped. Let me know if you still have any more questions. And remember, your quiz will be on Wednesday.